In this video, we are going to calculate the formula to calculate the length of the chord of a circle and also the length of the common chord. We will do this by two methods. So let us see the first method. Formula to find the length of the chord. Let's draw the figure first. Chord length formula using the perpendicular distance from the center of the circle and the radius of the circle. You are using these two concepts, that is formula using the perpendicular distance from the center and the radius of the circle. Oh, that is clear? Circle. This is a chord. Let's name the chord as AB. O is the center of the circle. The length of the chord is A. Okay. M is the midpoint of the chord. Because it's the midpoint, so it is dividing the whole length, that is the chord AB, into half. So this is AM is A by 2 and MB is also A by 2 because the total length is A. Now we join the center of the chord to the center of the circle. Okay. When you join the center of the circle, that means a line segment joining the midpoint of a chord to the center of the circle is perpendicular to the chord. So this is perpendicular here. That is, the angle is 90 degrees. Clear? If this is 90, this should also be 90. Let's join the radius. This is the radius of the circle. Let it name it, say it is R. R is the radius. This is the distance between the center and the midpoint of the chord. That is D. Okay. Now we apply Pythagoras theorem to this particular triangle. Applying Pythagoras theorem to triangle OMA, to this triangle, if you apply Pythagoras theorem, this is 90 degrees, so this is the hypotenuse. So it should be OA square is equal to OM square plus AM square. Let's put the values like RD is this. It will be AM square is equal to OA square minus OM square. We want to find AM. So that's why we are rearranging the terms so that OM goes to the side, it becomes negative. So OA square minus OM square plus is equal to AM square. Now AM, what is AM? AM is A by 2. OA is R and this is D. So let's put it. So A by 2 whole square is equal to R square minus D square. Take the square. So A square upon 4 is equal to R square minus D square. So take 4 this side. So A square is equal to 4 into R square minus D square. Take the root of that. Root is equal to square root of 4 is R square minus D square. But square root of 4 is what? 2. So let us take out 4 that outside. So chord length is 2 into root of R square minus D square. So this is the directly you can find the length of the chord by using the formula 2 into square root of R square minus D square, where D is what is R? R represents the radius of the circle. And what does D represent? Represents the perpendicular distance from the center of the circle to the chord. This was your first method. So this is clear? Now we use another method, that is we are using trigonometric method to find the length of the chord by trigonometric method. Again, let's draw the figure. Circle, chord, AB is the chord, O is the center of the circle. Let's join the two radius. Okay, perpendicular. These are the two radius because OA and OB are the radius of the same circle. So both are equal. And let the length of the chord be A. This is a perpendicular distance joining the midpoint. So this is the M of the circle. So this is perpendicular. So since it's the midpoint, it is A by 2, because the total length is A. And let this be perpendicular distance be D, as we did the previous sum. It's same thing. Mainly we are using trigonometry, means we'll use an angle here. So that let this angle be theta by 2. That means the full angle is theta, though this should be only half of that, that is theta by 2. Now let why it is half of that, we will prove it also. O is the center of the circle of radius R. Now joining OA and OB. So OA and OB are both radius, that is R centimeters. Chord AB is of A centimeters. Let angle AOB be theta, that is AOB. So AOB means this complete angle, that is we call it as a central angle. So the central angle is theta. Now OM is perpendicular to AB. This line OM is perpendicular to AB because I've already drawn the perpendicular. So in triangle OMA and OMB, that means these two small triangles we are taking. Angle OMA, that means this angle and this angle both are 90. OA is equal to OB. OA is equal to OB. Why? Because both are radius of the same circle, which is R. And OM, this line is common to both the triangles. It's a common side. Therefore, these two triangles, that is OMA and OMB, both are congruent. Why they are congruent? By RHS congruency rule. Because these two are congruent, this angle should be half of that. So angle AOM must be equal to BOM because they are the congruent parts of congruent triangle. The complete angle is theta, so this part for half the portion should be theta by 2. Also, AM and MB are also congruent parts, so that should be also half of the entire length. So it is A by 2. Now, so in triangle, now we take only this small triangle. In triangle OMA, we take the sine of this angle theta. So sine theta by 2. What is sine? Sine is opposite by hypotenuse. So opposite to sine theta by 2 is A by 2. So write A by 2 and hypotenuse is R upon R. So take R this side, it will become R sine theta by 2 is equal to A upon 2. Take 2 also this side. A 2R sine theta by 2 is A. But what is A? A is the total length. So the length of the chord is 2R sine theta by 2. This is by trigonometric method. Clear? So chord length is 2R sine theta by 2, where R represents the radius of the circle and theta represents the angle at the center of the circle by the chord. This is the okay. So this was finding the length of the chord by two methods. One was analytical method using Pythagoras theorem, and the second is a trigonometrical method by using trigonometric function, that is sine theta. Okay, hope you have understood it. If you are watching this for the first time, please subscribe for the thing and click on the like button. Now we'll do a common chord, a chord which is common to both the two triangles. Now let us see. Formula to find the length of the common chord. Let us draw a circle. We have another circle. So two circles intersecting. So let the centers of the two circles be M and N and AB be the common chord. So let us draw the centers. M and N are the centers of these two circles. M is the center of the smaller circle and N is the center of this bigger circle. And this should be the common chord. What is the common chord? Here, AB. AB is the common chord. Understood? What is the meaning of common chord? Now, MN is perpendicular bisector of chord AB at P. So suppose you join these two centers, it become a perpendicular bisector. It will be perpendicular to it. So joining it, so this will be intersecting at point P and it will be perpendicular bisector. Bisector means it divides this chord to two equal halves. That is AP and PB both must be equal. So the distance between the two centers of the circle, that is MN, this distance between the two centers of the circle be D. Let it take it as D. Let PM be X. So let us take this as X. And so if this total distance is D, so this is X. So I mean this should be D minus X. So Pn is D minus X. Join this radius. AM, radius R1 it is, radius of the smaller circle. Join AN. So let the radius of the first circle be AM is equal to R1. Join the second circle, that is R2. Radius of the second circle AN is equal to R2. Clear? So in triangle APM, now we are taking this particular small triangle. So if you take this triangle, here it is 90 degrees because I said it is already perpendicular. Okay, perpendicular bisector it is. So you apply Pythagoras theorem to this triangle, you will get AM square is equal to AP square plus MP square. Put the values. So R1 square is equal to AP square plus X square. So X square is equal to R1 square minus AP square. Clear? Now take the other triangle. In this triangle, this is the hypotenuse. So AN square is equal to AP square plus PN square. Put the values. R2 square is equal to AP square plus D minus X whole square. So let us take this one this side. So R2 square minus, so D minus X whole square will become D minus X whole square is equal to R2 square minus AP square. So this is clear. Now see here. So D minus X whole square. We are using the formula A minus B whole square formula. What is A minus B whole square? A square plus B square minus 2AB. So A is D. So D square. X is B. So D square plus X square minus 2DX minus is equal to R2 square minus AP square. So D square. Now what is X square? X square is R1 square minus AP square, which I have written here. So it is R2 square. So D square is plus R1 square minus AP square minus 2DX is equal to R2 square minus AP square. Both are negative. Minus AP square minus AP square. They got cancelled. So what is left? RD R1 square minus R2 square plus D square is equal to 2DX. Okay, a little bit of arranging the terms. Instead of keeping the last day, I brought it there. Now let us take dx down. So once you take R1 square minus R2 square plus D square upon 2D is equal to X. Okay. Now R1 square minus R2 square plus D square upon 2D. And what is X? X was R1 square minus AP square. And X is, so X square is this. So X must be the square root of this. If square root is there, let us remove the square root by taking the square of both sides. When you take the square of both sides, this whole square is equal to square of this. So because of this square and root they cancel, it will be only R1 square minus R2 square plus D square upon 2D bracket raised to 2 is equal to R1 square minus AP square. Take AP this side and bring this full bracket this to the left. It becomes AP square is equal to R1 square minus this whole thing. Now you see here we need to simplify this root because AP square it is, we need only AP. So we take the root of that. Root of this. So AP is half of the whole chord length. So multiply by 2 on both sides. So 2AP is equal to 2 into root of this. 2AP is nothing but AB. AB is equal to this. So length of the common chord is 2 into root of R1 square minus R1 square minus R2 square plus D square upon 2D whole square. This is the length of the common chord. Understood? So when there is a common chord between two circles, this is the formula for finding the length of the common chord. Now we take one special case, okay? And the same formula, we modify it when there is a special case. Now let us see what is the special case. So here what is it? Here R1 and R2 are the radius of the two circles. And what is the distance? D. D is the distance between the centers of the two circles. Okay. So R1 and R2 are radius of the two circles. Now in a special case, now we have a different condition. See, special case. Now we take a special case. Two circles intersect orthogonally. Now what do you understand by intersecting orthogonally? The two circles are intersecting orthogonally if the angle between the two radius is 90 degrees. That means two radius are perpendicular to each other. So let us draw the figure again. I won't explain much again. I'll go faster. D is the distance between the two centers. This is the MP is X, Pn is D minus X. This is the R1, radius of the first circle. This is R2, radius of the second circle. And these two are perpendicular to each other. So here the angle is 90. So here the angle is 90. That is a special case of this. When that angle becomes 90, now if you see this, if this is 90, then this becomes a, that is MAN becomes a right angle triangle. Once it's a right angle triangle, we can apply Pythagoras theorem and MN is D and A R1 and R2. So it should become R square, R1 square plus R2 square should be D square. So in triangle MAN, Mn square is equal to Ma square plus Na square. Ma and Na are R1 and R2 and Mn is D. So put the values. So this is, we are doing by Pythagoras theorem. So D square is equal to R1 square plus R2 square. But we just learned the length of the chord AB by a formula. This was the formula which we have learned. Now in the same formula, what we do, in place of D square, I am going to substitute this value. So when you substitute the value of D square and D in the above formula. Because denominator we have got D and the numerator we have got D square. Put the values here. R1 square minus R1 square minus R2 square and D square is what? R1 square plus R2. R1 square plus R2 square upon D will be root of this. So 2 into root of R1 square plus R2 square and whole square. This square is this square. Now this is R minus R2 square plus R2 square should get cancelled. So these two get cancelled. So what is it? R1 square plus R1 square. So what has happened? 2R1 square is there. So R2 R1 square upon 2 R root of R1 square plus R2 square. Again 2 cancel. And so cancel that. What is left? R1 square into R1 square whole square upon R1 square R2 square. This square and root they cancel and is only this root vanishes of only R1 square plus R2 square. Now take the LCM of this whole thing. When you take LCM, so this should multiply with R1 square plus R2 square. So R1 square into R1 square plus R2 square minus R1 square will become R raised to 4 upon R1 square plus R2 square. Now open the bracket here. Once you open the bracket, see R1 square into R1 square will be R raised to 4 square plus R1 square into R2 square. This is R1 square into R2 square minus R1 square. Again plus R1 square minus R1 square cancels. So we are left with AB is equal to root of R1 square R2 square upon R1 square plus R2 square. But R1 square plus R2 square is D square. So let's put the value there. So 2 into r1 square into r2 square upon d square. Now all these are inside the root sign and they are all the squares. So this r1 can come out, r2 comes out and d also comes out. So it becomes AB will be 2 r1 r2 upon d. So this is the formula where when the two circles are intersecting orthogonally, that is the radius of the two circles are perpendicular to each other. Understood? So this was a special case. See, the formula has become so simple. Only if this condition is, and this is applied only for when this two radius are perpendicular. If it is not perpendicular, then this is the formula which is applicable for all the types of circles. The radius, okay, when the circles are of different radius and the radius are not perpendicular to each other, this is the formula. If it becomes perpendicular, the thing gets simplified in this form. Hope you understood it. So don't forget to subscribe for the channel and share it with your friends.